And information channels, already we have taken 14 classes. It is the 15th class we are discussing now. It is a new chapter. According to the syllabus, number of hours prescribed, the same number of hours we are taking because of this online. Otherwise, usually we take more classes. Now let us go to this particular chapter, information channels. So this is a unit 3 what we are going to discuss. Already unit 1, unit 2 have completed, and unit 3 we are going to discuss a communication channels, discrete communication channel, channel matrix, joint probability matrix, binary symmetric channel. These things, if possible, we will try to discuss in today's class. It's offline. If it's offline, we usually ask you to write a block diagram, but it's an online class. I want you people to type all the blocks at a time in the chat box. Take 1 minute, type all the blocks in the chat box. Hope all of you know the block diagram of a digital communication system. I want you people to type in the chat box the blocks. I think you have done it already once. The same thing you have to repeat now. In this chapter also, the same question I am asking. Type the block names fast. If somebody typed, others will start. Okay, good. Aditya Hiryamata has typed. Source encoder, good. Try to type all at a time. Harsha, Vineet, Harsha Nagalinga decoder, she has typed. Channel encoder, Sumit, good. Amrita, at a time, Shilpa has typed. Very good. Source, transmitter, modulator, receiver, not perfectly, Shilpa, but anyway, Priya has typed source encoder, channel encoder, very good. Nobody has typed all the blocks at a time. Take another 1 minute. Input, signal encoder, channel output signal. Somebody has typed Geeta, no, not correct completely. Channel encoder, modulator, transmitter, antenna, Aditya, one side he has typed. Devidas, source encoder, channel encoder, modulator, transmitter, one side it is correct, Devidas. And I want complete all the blocks. I think PPT is not responding, but anyway, you can type it. Source encoder, channel encoder, modulator, Praveen Patil, correct. I want all at the receiver side also, complete. Rohit, Savalgi, Preeti has typed transmitter, okay. And whole communication system means you have to include receiver also. Very good. Nivedita has typed almost all. Source, decoder, information source, everything she has typed. Nivedita. Very good. Let me go to the next slide. Shivani has typed. Rahul Raj is typing. Abhishek Kulkarni has typed. Very good. So this is time. Okay, Srijana has typed very nicely. Thank you, Srijana. Source encoder, channel encoder, modulator, transmitter antenna, channel receiver antenna. Then she told demodulator, channel decoder. Then source decoder she is supposed to type. Very good. Shruti has typed very nicely. Let us go to the next. Thank you, everybody. Let us have block diagram. Anything is wrong in this? You tell the block which is wrong or something is wrong if you feel. You have a few seconds with you. Let me know who will find out something is, if something is wrong in any one block. Tell that block name. Fast. That shows nobody is authoring the PPT. Visible or not? Yes, source encoder, it is not at all there. Thank you. But actually here, source encoder will not come in the communication system. It is before the communication system source encoder will come. Any other thing is wrong? Source encoder will not come. Preeti, Pragati. Very good, Maitri. It is a modulator which is missing. And actually, Praveen Patil has also told modulator. This I have taken from the internet as it is. But later I came to know that something is wrong. Then I have made changes. I wrote a modulator. Just read the below whatever you have given. C to G is a coding channel. D to F is an electrical channel. C. D to F is an electrical connection, and C to G, what you have taken, it is a coding channel. So let us go to the next. Draw the discrete digital analog signal in your notebook. Usually we used to tell in the offline classes. Now you have to make changes. Type something, some voltage level, something what you know about these three in the chat box. Digital signal, discrete signal, and analog signal. Somebody can type 1 line, 2 lines, whatever you know. Hope you have heard all the three. At least you can type for one also, no problem. No need to type all the three answers. You can take a few seconds and type any one at least which you are comfortable, for which you know a better answer, you can type. Even the answer is wrong, no problem. I want you people to type whatever you know in the chat box. Voltage below 1 kilovolt is a low voltage. Nivedita is typing, okay. I am talking discrete and digital, and third word is analog. Difference between these. Bharat Kulkarni has typed something, very good. And Nivedita, you try to tell again one more answer. And discrete, digital, analog. The difference between these three words. Somebody has to tell. Nearly 59 students are there in the class. I'm sure most of you know. Okay, somebody want to tell answer, you can unmute also. Tell the answer. Shivani has typed analog sine or cosine wave. Okay. Vijay Lakshmi has typed analog is continuous signal. Very good. Rohan has typed digital is 0, 1. Analog varies with time. Okay. Vidya has typed analog is a continuous signal. Okay. Parameshwara. Digital has only 2. Very good. Nobody is talking about discrete. Somebody, Arjun Ambekar has typed. Okay, sample value, digital is a binary. Arjun, very good. Arjun. And the digital signal easy to modulate. Harsha is telling. Shilpa, digital is distinct. Prajakta is telling analog signal is difficult to debug. Okay, but Arjun has told some answer. Ambekar, very good Arjun. Anybody want to type? Just try. Thank all of you for typing your answers with the right or wrong. You have active 60th person has joined now. I want all 60 to type. Try whatever is there in your mind. Shilpa is typing. Gaura is typing. Digital signal represents sequence of discrete. Gaura is typing mixing. She is mixing digital and discrete. Okay. Geeta is typing discrete is a sample of analog signal. Okay, good. Something they are telling. Even though answer are not perfectly correct, analog denoted by sine wave. Preeti is telling. Parameshwara, discrete is a specific signal. Okay. Analog signal has a sinusoidal wave. Ankita Shetty. Simran, digital is discrete. Okay, Simran, thank you. Answer is not correct, Simran, but thank you for giving the answer. Parshvanatha, digital is only 2 values, sir. Very good, Parshvanatha. What you told is perfectly correct. I'll show you the answers. You should know these answers, at least being an electronics and communication engineer. You should know these answers. And Nivedita, clock is what she didn't tell, only clock she told, with that maybe digital she want to tell. Digital is a binary value. Okay. Jaisuri has told digital both x's are discrete, sir. Discrete, one axis discrete and one axis is continuous. Okay. Digital clock she told digital. Nivedita, good. Rohit Savali is telling analog sampling, discrete, quantization, digital. Okay, something he has told. Very good, Rohit. Okay, let me show you the answers. Ajna is telling discrete signal are discrete. Discrete signals are discrete. Okay, in time and amplitude. Okay, thank you, Ajna. I'll show you anybody has written. You just try to write a waveform in your notebook. I'll give you another 10 seconds. Then I'll go back to I'll give the 5 seconds. Just I want you people to write in your notebook something. Waveforms you write. All the 3 waveforms. Take a 10 seconds. I will show you the answer after 10 seconds. Write something. Even the right or wrong, just write in your notebook. Because you cannot show that. Okay, I will show you the answer. Just compare. And remember this. Even though you do not remember all ITC, what I am teaching, no problem. At least you are supposed to remember this much. Analog. Somebody told. Sine wave, sir. Cos wave, sir. Yeah, it's correct. Discrete you have studied in your signals and system. Discrete you have studied. It is like this. A different values are there. Say 0.1, 0.2, 0.3, something like that. But when I say digital, only 0 and 1. Nothing else. Only 2 labels. This is a digital. It is a discrete. This is a continuous. One should remember these 3. Because why I told in our information theory and coding subject, we are going to talk about discrete channel. Discrete channel is different, digital channel is different, continuous channel is different. One should not ask, what is a discrete channel, sir? So where we transmit this type of information, discrete means you can understand. Digital means only you can send a 2 level. Analog means you can send infinite levels. This is one important point which everyone has to know and remember, being an electronics and communication engineer. Let us go to the next. Each one of you should answer for these questions, and everybody know the answer. I want you people to type your answers in the chat box fast without bothering what others are typing. Okay? Don't take much time. Maximum time is only 1 minute. Do it fast. Everybody know the answer. Read it. Type the answer. Are you ready? See here. You have 1 minute. Just type it fast. Advantages of online classes. Let me know from your side. Faster. Okay, good. Next. Interactive. Faster response. Interactive. Easily understandable. Faster. No distraction as in class. Interactive. Fast. Response is very fast. Okay. Any other technological? Interactive. Some words you can type. More responsive. Everyone is active. Very good. Everyone is active. Highly interactive. Connecting to everyone in the less time. It's so true, Shruti. Charan, more topics can be covered in the online. It is true, Charan. Prajakta, super active. Thank you. Parameshwar, fast. Highly effective, Rahul Raj. Very good. Spurti, documentation will be there. Very good. It is true. Funny sometimes. Safe. Yeah, we are a little bit free in home, sir. Prithviraj, perfectly correct. All can answer at a time. It is 100% true, Nivedita. Aditya has told no need of getting ready. Yeah, this is true for even girls also, Aditya. Vinay Giriyan, never. Recording and listening is possible again and again. Can offer from anywhere in the world. Yes, we can record and play back if we have doubts. Abhirup Joshi has told. Perfectly correct. And Maitri has told can be documented. Yes, 100%. Learn the recording of all these classes and you can listen again. Rahul Raj, productive. If somebody has recorded all my classes, you can share in the classroom. Harsha Nagaling, parents will be happy to see you studying. So interesting. Very, very true, Harsha. Parents will be very happy you are using a mobile for education purpose. Yeah, definitely parents will be happy. Geeta, we can save the time. Definitely we can save the time. We can be comfortable in our room. Very true. Shripad, attentive than offline. I do agree with this. Many students are doing all the work assigned in the online class. They are even giving the answer in the chat box. I do agree with these answers. Comfortable learning. Srijana, thank you. Don't feel sleepy. It is true, Spurti. Thank you. Any other advantages? If anybody want to tell, you can tell. So let me go to the next. Another question. Whenever we are never thought of otherwise while answering. Yes, Vidya Kalkir, it is true. In the offline class, they don't want to answer, but in online, simply they can type it. Many students, even almost all students, they are giving the answer. I'm very happy with the online classes rather than offline. So anyway, but both are having some advantages, disadvantages. And next question, also everybody knows. We'll see how many answers I'll get for this. Disadvantages of offline classes. You can type that also. Let me see some points. Lack of network problem, connectivity problem, then network problem, some connectivity problem, connection problem, network issues, classroom environment will not be there. Sripad, I do agree. Network problem, sometimes we get distracted by guest. Okay, network issues, need to keep notes up to date. Okay, connectivity issues, low power supply issues. Sometimes we leave class and walk around. Prithviraj, it is true. Depending upon the teacher, sometimes some will be roaming in the room after online classes. That is true. And the lecturer may don't know what students are doing. Ajna, it is perfectly correct what you told. Nobody will come to know. I think I am only one person, if I am right, who is seeing the chat box continuously when I am talking. Laziness will be the projector for some time. Children, technology issues, sometimes it is true. Eyes paining, Saujanya, it is true. Abhiroop, effects on eyes, yes. Maitri Gopinath, other notifications might distract, yes, it's true. Whenever your WhatsApp give the ring, yeah, it is true. Disturbed by homes, okay, it is true. Some people will be calling, some people will be talking, though to take notes, okay. Even difficult sometimes to note down, but you can record or project if possible. You can keep videos also, but the online classes, it's difficult to dictate the notes and all. If possible we try, but it's difficult like offline classes. Thank you all of you. Let me take all these things and dump in my today's class chat box, and then I will continue the class. Thanks for responding, giving the answers, and most of the answers I agree whatever you have given. And it's not related to the subject, but we should know what are the advantages, what are the disadvantages, and we'll be knowing, but we want to listen from you also. So let us go to the next now. We can't discuss to colleagues, okay. It's possible you can have your own Google Meet, even if you are interested, even I can schedule, only just for a discussion, and another discussion you can do in your classroom also. Somebody can ask the question, other students can answer for that question. We can do that. Sir, we want to discuss online. We want to see each other's face. That also can be done. We can have a meeting. Somebody can ask the question. Other student can answer. We can have that interactive session also, so that we can see each other. Whenever asking a question, whenever somebody is answering, we can see each other. That also we can have one day if you schedule. All of you are agreeing. So let us go to the next now. A memoryless channel means what? Just read it once and try to understand. Take 1 minute maximum. If the occurrence of an error during a bit interval does not affect the behavior of the system during other bit interval, then I can say it's a memoryless channel. Read it again. If the occurrence of an error, you can note down also. If the occurrence of an error during a bit interval does not affect the behavior of the system during other bit interval. I'll pause. I will wait for another 25 seconds. Then we'll go to the next. Those who are interested can copy down. Otherwise, they can read it twice and thrice so that they can remember. Okay, let us go to the next slide. A discrete communication channel. Read this. What is the meaning of discrete? Just now I asked this question to you people. This is the reason why I asked. Just read it. A discrete communication channel has an input x and output y. Both x and y are random variables. The channel is discrete when both x and y are discrete. You should know meaning of discrete. Digital is different. Analog is different. Discrete is different. The channel is called memoryless when the current output depends only on the current input. I'll give you the 2 minutes. You can copy down or you can read it twice or thrice and try to understand. Discrete communication channel has an input x and output y. Both x and y are the random variables. The channel is discrete when both x and y are discrete. Digital is different, discrete is different, analog is different. So I'll wait for another 10 seconds, then we'll go to the next slide. Okay, let us go to the next. The channel is discrete in terms of input alphabet, output alphabet, and the set of transition probabilities. The transition probability is a probability of yj given xi is a condition probability of yj received given that xy was transmitted. I want you people to read this twice. The meaning of this is yj is received given that xi was transmitted. The meaning of this is if I equal to j, then represents a conditional probability of correct reception. I am sending A, I am receiving A. I is not equal to j. I am sending A, I am receiving C. Then it represents the condition probability of an error. I want you people to understand these 4 lines. Read it twice, thrice. Even you can copy down a part of that notes also. I will wait for another 30 seconds. Probability of yj given xi is the condition probability of yj is received given that xi was transmitted. Another 10 to 15 seconds I will wait. You can copy down. If you don't want to copy down, you can simply read it twice and thrice. Understand. So let us go to the next. I have a source. Okay, transmitter you can say. It's a receiver. In between I have a channel. And I am sending a x1 up to xm symbol. And at the receiver I am sending y1. I am receiving y1 to yn. Remember, this is m, this is n. In some textbook they take m and m only. Both will be same. In some textbook they take m and n. Why? We'll see it. X and y are discrete. All of you know the meaning of discrete, not a digital, it's a discrete. And it's a memoryless, meaning is that input current, if current output only depends on a current input, I can say it is a memoryless. And channel we represent by probability of yj given xi. I want you to just see it, or if you want you can copy down. You can take a 30 seconds for that. Source, I have a channel, I have a destination. You can take transmitter and receiver also in between channel. And transmitter side I am sending x1 to xm. Receiver side I am receiving y1 to yn. And channel I am representing by probability of yj given xi. So how I represent? Source is nothing but a transmitter. We use it as a source. Receiver I have. This side I have x, x1, x2 up to xm. And in some books they take ym. In some books they take yn also. X is nothing but a symbol, belongs to an alphabet of m symbols. Y is also a symbol, belongs to some alphabet m symbols. So just take a 1 minute maximum. You can copy down. It's a transmitter. I have a receiver. I have a channel. These many I am sending. I may receive these things, and the probability I am using to represent the channel. So let us go to the next. If you have taken a source x, receiver y, in between channel, probability of yi xi or yj and xi you can write. In some books they change also. In some books instead of x and y they may take a and b. Let us go to the next. So this transition probabilities of the channel. I may send a x1, I may receive y1. I may send a x1, I may receive y2. I may send a x1, I may receive y3. I may send x1, I may receive ym. So copy down the transition probability. Similarly, I may send a x2, I may receive y1. I may send a x2, I may receive y2, like that up to the last row. Take a 1 minute, copy down. This you have to copy down, because we use this for our later discussion. We need this transition probabilities. Copy down and try to understand. P equal to is nothing but probabilities, channel probabilities I am writing, transition probabilities of a channel. And in some books they may take n and n, they may take m and m. In some books they take m and n, no problem. The concept you have to understand. Let us go to the next slide. Okay. See, the above matrix has size of n and m. It is called a channel matrix or a probability transition matrix. Both are same. This you have to remember. And each row of the above matrix represents a fixed input. I told you I am sending x1, receiving y1. I am sending x1, receiving y2. I may send a x1, I may receive y3. When I add all these probabilities, it should become equal to 1. When I am sending x1, I should receive any one, either y1, y2, y3, y4, y5, y6 up to ym. When I add all these probabilities, it should become equal to 1. That is the reason it is given this line. The summation of all the transition probabilities along the row is equal to 1. This you have to copy down. At least these two lines. These two you can read it. These two you have to copy down. Understand this line you have to copy down. Take a 1 minute maximum. The above matrix has the size of n cross m. Each row of a above matrix represents a fixed input. First row is a x1, second row is a x2. Like that we have. The summation of all the transition probabilities along the row is equal to 1. Let us go to the next. Similarly, whatever I have taken, it is just for a one line. First row, it is true for a remaining rows also. Means I can write a second row, third row. This is applicable to other rows also. Therefore, in general, I can write summation j equal to 1 to m, yj given xi equal to 1. This is true for first row, second row, third row. Therefore, in general, I have written. In some books, instead of x and y, a and b are used. Take a 1 minute, just copy down these 3 lines. And write down, instead of x and y, a and b also used. Because in problems, we may use a and b also sometimes. We may use x and y also. If they give a and b, it's the same way. Instead of writing here y, I have to write b. Wherever x is there, I have to write a. Take another few seconds. Equation 1 you have to remember. Then we will continue our discussion now. Let us go to the next. See, why this condition probabilities? The condition probabilities came into existence due to the presence of God. I mean to say, I told in previous classes also, God is everywhere. This was taught to us when we were kids. But we say, being engineer, noise is everywhere. Because of this noise, definitely the condition probabilities come into picture. Because of this noise, there will be some amount of uncertainty. If I send A, I may not receive A at the receiver, I may receive B. If I am sending C at the transmitter, at the receiver I may receive B. This is because of the presence of noise, because noise is everywhere. For this reason, we have a different number of symbols, M at the receiver, N at the transmitter. In some books they take. Take a few seconds, read it, understand it, and if you want, you can take a few words from this particular slide. The condition probabilities. Why, sir? When I am sending A, I should receive A, na? Yeah, it is true, but impossible, because God is there. Wherever God is there, we say, noise is there everywhere. Therefore, whenever you are sending A, it may be received as B at the receiver. This is one important point which you have to remember. And don't write these things, God and etc. in the exam. It is just for your information, just for you people. So let us go to the next. and somebody will be knowing, asking reason why m and n. This is one line, you have to read it. Let us go to the next. This you already copied. I did this, but it has come again. Okay. Not need it. Okay, the same what I have told you. Just see it. Take a 10 seconds. Whatever I have told, the same slides are there again. Made it hidden, but again these are coming. Okay, anyway, let us go to the next. So this you have copied just now, equation number 2. It's applicable to other rows also. Hence we can write this. This you have copied just now. Let us go to the next. Yeah. For the fixed input xj, the output can be any one of y1, y2, ym. The summation of all these possibilities is equal to 1, and this you have taken just now. From the probability theory, we know that probability of AB equal to probability of B given A, probability of A. This we have discussed many times, and let us take the same equation I am rewriting. Let A equal to xi and B equal to yj. Then instead of writing AB, I can write xy. And sometimes we use a AB, sometimes we use a xi. The same equation I am rewriting using a x and y, and we use this in our discussion. Just copy down this. What I am doing, the xi and yj is the joint probability of xi and yj. Here actually AB I am using. In the previous chapter and all we have used. If we add all the joint probabilities for the fixed yj, then we get yj. So this equation you copy down. I think equation number 2, previously what you have taken, okay, same equation. So copy down this equation number 2, 3 and 4, so that we can write a fifth equation. This we have discussed and solved many problems also. I hope you people may be remembering. Chain rule we have discussed, and black, white balls. Some problems we have solved this using the same concept. There we have taken A, B, C. Let us take A capital equal to xi, B equal to yj. Simply I am rewriting. And this is nothing but a joint probability. And when I add, I will get a yj. So this much if I know, next equation I can write. So I'll wait for another 10 seconds. Just copy down the equation number 3 and 4. Then we'll go to the next slide. Take this as a homework. I think this is available in the YouTube, relation between the joint and conditional entropies. You can just note down the word. Take a 10 seconds if you want. I want you people to just a minute. Okay, 10 seconds I'll give you. Take a relation between the joint and conditional entropies. A derivation is available in the YouTube, my channel only. You can go through once. So let us go to the next. Yeah, we have equation number 3 in your notebook. You are already having equation number 4. What I am doing, fill the equation number 3 in the equation number 4. I am rewriting and I am giving the equation number as a 5, where j equal to 1, 2, 3 up to m, and I equal to 1 to n. This equation we use in our discussions. So before we go to this channel discussion, so I may spend a few minutes with a general another question related to this only. Then I'll come back to this equation number 5. So let me go to the, I will wait for another 5 seconds, copy down the equation for 5. Now we'll go to the next slide. Okay. You have studied, if I am right, impulse response in your signals and system. I think a separate chapter was there. And why you studied impulse response? What is the significance? What is the need of studying an impulse response of a system? Those who have studied days and days, they should tell. Answer may be wrong, but I want you people to just tell some answer, even though it's a wrong. What is there in your mind? Let me see. Okay. Anybody is typing impulse response? Even though it's wrong, no problem. I want you people to type transfer function means what? Any one answer, either that or this. I want you people to type. Think that it is a interview is going on. Even though your answer are wrong, I appreciate because you are giving the answer. Always something is better than nothing. Nivedita, thank you. To know response of the dynamic system. Okay. Abhishek Kulkarni, reaction of a dynamic system. Okay. Impulse response you have studied. It is the result of a system due to external change. Okay, Shripad has told something. Thank you. Have you studied like a square response of a system, sine wave response of a system, to know the device output? Okay, Harsha is telling something. Laplace transform of output to the input. Prajakta, very good. Transfer function she may be telling. Impulse response, why I studied? Transfer function output to input. Saujanya is telling, good. These two are having a lot of meaning. Laplace transform of output to input. See, this Karthik is also telling, I do agree, but I don't want a textbook definition. What you are remembering, I don't want. What you understood, I want. So there is a difference between what you are remembering, what you understood. Chaitra Kulkarni has typed something I appreciate. Chaitra, thank you. Saujanya is telling to know the stability of the system. This is also a little bit okay. Saujanya, thank you. Shilpa is telling the equation, transfer function is the output by input. But what you understood from that? I don't want what you remembered. Remembering is different and understanding is different. Most of you are remembering equations. I want what you understood out of that. Nivedita is telling initial conditions will be 0 for something she is telling. Okay. Anybody else? Somebody might have scored highest marks. Somebody might have told their interest subject is signals and systems. They want to do something in the DSP. Such students should be very good in this impulse response and transfer function. Even though, as I know, I have not handled these subjects, but I love these subjects. Anybody? Impulse response. Somebody is Googling. Somebody may Google it and I don't know. Anyway, I'll give another 10 to 15 seconds. We'll see. Somebody will tell the answer. That shows you have not understood anything. At any point of input response can be found. Vidya Kalkari is telling a little bit and not complete answer what I expected. Devaraj transfer function is to construct the system. Okay, Devaraj is telling some answer. What I expecting from you people is a complete perfect answer. Anybody can try. No. So that shows whatever you have studied 50 hours, not 50 hours, actually 50 hours is a syllabus. You might have studied another 50 hours to write the exams, CAT and all. 100 hours you might have spent on signals and system. And you didn't understand anything. Then, according to the interview, if they ask like this, they say you have not done anything. Transfer function was says about the stability of the system. Chaitra Kulkarni has told something very good. Adni impulse response is the inverse Laplace transform function. Okay. Majority are telling the equation. Equation I don't want. What you understood that I want. Nobody told. Okay, let us think. I know the transfer function of a system. What is the use of it? I know the transfer function of a system. Is there any use of that? At least answer for this question. It's very simple. मुझे ही ट्रांसफर फंक्शन मालूम है एक सिस्टम का. Abhishek is telling used to solve algebraic equations. Anybody else? Use क्या होता है उसका? We know the output to each possible input. Sumit Desai is selling something. Very good, Sumit. Anybody else? I want a perfect answer. I know transfer function of a system. What is the use of it? क्या करेंगे आप उसे लेके? Why should I know? Adnya has told something. Thank you, Adnya. Anybody else? Try. 58 students are there as of now. I want 58 answers. Whether they are right or wrong, I don't know. No problem. You are supposed to type. Parameshwara used to identify the state of the system. Okay. Anything else? Arjun, we can calculate before implementing. Okay. We can find zeros and poles. Shivani, okay. Why you do that? Prajakta, based on that we can say it can be constructed or not. Okay, good. Prajakta, any other answer? I expect one answer which is needed for my discussion, ITC, which is needed for my channel probability. It is a mathematical model of system to represent the input-output relationship of a system. Abhishek, you are on the way, but not a perfect answer. To know the behavior of the physical system, Nivedita is correct a little bit. Anything else? Even it's the equation only what I am asking. If you know the transfer function, what is the use of it? To know the relation between the input and output, Vidya, you are also on the way, not perfect answer. You know the transfer function. What is the use of it? Can find the stability of the system, Jay Surya. Okay, any other thing? So again, I am giving the clue. You know the input. Agita is typing single input, single output. To know the reaction of the input, here Rahul Raj has told something. Very good. To see the changes in the system, Vishwa is telling. Shilpa Sambrani, to know the relationship between the input and output and stability. Okay, any other thing? Answer is on the slide. Vineet Sakaria has told perfect answer now. Thank you, Vineet. The output can be easily determined for a given input once if I know the transfer function of the system. Vineet, this line I expected. But you told after showing this particular slide because answer is there in this. Transfer function represents the behavior of the system. Yeah, Ritika, correct. Now, this, can you read it? May not be able to read. Let us see this. Read it. I'll give the 30 seconds. The same thing. Huh? Somebody has told about the transfer function. Just I am copying and pasting. Understand, read it, and try to remember the transfer function. Why I asked about a transfer function? The same way I can talk about a channel probabilities. Once if you know the transfer function, simply multiply by input, you will get output. Sorry. So similarly, how we can use a channel probabilities we are going to discuss. Take a next slide, continuation of this. It is there in the next line. Read this also, take another 30 seconds. These lines are very important, and I want some student to make a big list of such questions and answers. Even you can present also. Even in my class, I'll give a few minutes for you if you are interested to present in my class, so that all 60 students will get the answer within a few minutes. So let us go to the next. You can read it again. I don't want to read. What you told is these things. Correct. Most of you have told the same answer. But what is the use of transfer function? If I have a transfer function in my hand, what is the use? That was a question I asked later. For that, only few students they answered. So let us go to the next. Similarly, if the transition probabilities are known and input symbol probabilities are known, simply multiplying these two, output symbol probabilities can be found. This one line I wanted to tell. That's the reason I asked about these two. Simply if I multiply these two, I'll get a output symbol probability. That's the equation number 5 what you have copied. Just take a few seconds and note down this one particular line, or remember, I think next slide I have copied the same lines. I'll give another 8 seconds. You can just read it, try to understand. And I'll try to remember transfer function, impulse function. Impulse response, anybody told the proper answer? After this, I'll pause for a few seconds. You can tell that. Yes, this you can copy it if you want, or read it twice. This is like a transfer function. Now let me know, anybody want to say about impulse response? Why you studied impulse response? Is there any chapter was there for I think in lower semester signals and system impulse response? You didn't study a sine wave response, cos wave response, staircase, something like that. Step response. Usually you have studied the impulse response. Let me ask you that question, why so? Then you can go to the next binary communication channel. Will go. Anybody can answer, you can unmute, you can answer, you can type and answer, no problem. Anybody? I'll give the another 15 seconds. Till that time, I'll copy all the content, whatever you have typed so far. I'll take another few seconds. Now let me finish this copying work and I'll give the time now. Yeah, I'll see the chat box now. If somebody has typed well and good, otherwise we'll go to the next. And nobody has typed anything. So nice. Hey, impulse response, why you have studied? Who has scored S grade in the S and S? They should answer. That shows there is no relation between what you have understood, what you have scored. That's the reason they won't believe your marks. Any industry, they never believe your marks. And remember, based on your marks, you will never get a job. Marks are different, knowledge is different. Many times. Let me see who will type. Why impulse response? You have studied. Why not sign response? Anybody? You can unmute and you can tell, no problem. I'll wait for another 10 seconds. Otherwise, we'll go to the next chapter. Sripad, response of a system at any arbitrary point. Okay. Oh, know how the system will behave against a signal at a particular impulse frequency. Abhishek has told. Very good. I agree. Abhishek and Sripad, what they are telling. I want a little bit perfect answer. The output is simply an input signal controlled with the impulse response. Something Chaitra has told. Okay, good. Chaitra. Anybody? You can tell allow us to calculate the output of the system. Ritika told, okay, good. To find properties of a linear time invariant system, Adya, very good. When I say again, when such questions comes, remember, this is the way how you can tackle a person when he is asking some questions. Like Adya, what she did, she told something, one linear time invariant system. Definitely when you give such an answer to the person who is asking a question in the interview, what he will do, he will ask the next question, what do you mean by linear? What do you mean by time variant? What do you mean by time invariant? Those will be the questions you can expect from the person who is asking the question. So this is a way how you can take him according to your path. There are two methods. You can go according to him or you can drag him according to you. But you should know the answer of linear, time variant, time invariant, non-linear, time variant, time invariant. Then you can drag him to your side and you can give the answer so that he will get selected in the interview. Shilpa has told it can be calculated using convolution integral of a arbitrary input. Very good, Shilpa, correct. And let us go to the next. Vijayalakshmi has told it's a reaction of a dynamic system in response to some external change. Okay, it gives the behavior of a system at a particular point. Okay, what all of you are telling is correct. क्यों चाहिए impulse response? मालूम क्यों चाहिए आपको? What is the use of it? Okay, you know the impulse response of a system. What is the use of it? You can type or you can unmute and you can tell. It's a means to study the system behavior and power. I agree, Simran. How? कैसे मालूम होगा आपको? Impulse response मालूम है आपको? क्या use होगा आपको? What is the use of that? How do you take use of that? Anybody can unmute and tell, or you can type also. Both are okay for me. Or you can go to the next slide. All are okay for me. These out of syllabus questions are very important. To design an efficient system, Parameshwar, okay. Stability, Shivani is telling, good. And study the output response, Harsha Nagling, okay. How, madam? How do you do? आपको मालूम है सही impulse response of a system क्या करेंगे आप लेके? What is the use? Why you want only impulse response? Why not sign response? Why not pause response? Why not step response? Why not some other response? Abhishek has told, find the system response for all distinct impulses. I want one answer. One line answer is there. I expect that answer from somebody out of 60 students. Anybody is getting? Okay. Somebody should get that answer. Anyway, now come back to the binary communication channel. Binary means all of you know 0 and 1, like a digital or binary. I am sending 0, I may receive 0, I may receive 1. I am sending 1, I may receive 0, I may receive 1. And these are the probabilities. 0 is sent, 0 is received. 1 is sent, 0 is received. 0 is sent, 1 is received. 1 is sent, 1 is received. I can say it is a symmetric if and only if P00 equal to P11 equal to same values. Copy down this and try to understand. Find the system response for all distinct impulses. Abhishek Kulkarni, it's true. I expect one more line. How come? How possible? वो कैसे हो सकता है आपको? आप कैसे करेंगे? Abhirup, output can be calculated by convolving the input signal with the impulse response. Okay, good. Abhirup. Correct. Some other answer I expect, like Adubhasha, what we call. Using that, even you can tell in Kannada also, no problem for me. But whether you understood or not, that I want to check. I take another 10 to 15 seconds and copy down. This model can be extended to the general case where m is greater than 2. I think here I have only 2, 0 and 1. I can have more than 1. Modems, 8 distinct level of waveforms also possible. So let me go to the next. I'll take another 2 minutes, we'll wind up because we will be having another class. Let me see who will tell. BPSK, QPSK, Kaunsa Chai, why. You may be having a Python class. Take a 2 minutes and answer for this. Sudden change in output when input is changed can be calculated and we can design the system more efficiently. Sripath has told. Very good. Anybody want to tell something about BPSK, QPSK difference? Kya hai uska? And this is a concluding slide for today's class because we have one more class, Python. Anybody want to tell anything about this? You are welcome.